So, hello everyone, and welcome to this weekly session that we conduct, Ask AuxEn Anything. And as you all know, that this is an online platform for civil structural engineers to interact with us and ask their queries or doubts related to any project that they are doing, or RCC steel design concept, or any site or construction issue that they are facing. So, this is the 41st such session that we are conducting, and let us begin by taking up the queries from the Google form. So first we will take up the queries from Google form, then we will take up the queries from email, and then from live comments. So let's begin. So the first question for this session is has been asked by engineer Anshuman Adhikari. He is from Guwahati and he is a working professional and an independent consultant. So he is saying, please throw some light on seismic design of SMRF plus shear wall system. Also suggest tips for economizing it. SMRF plus shear wall. So he's talking about a dual system that is to be adopted. Moment frames plus shear walls. Throw some light on seismic design. Also suggest tips for economizing it. So tips, I don't know tips. What are tips? Any tips from the audience? What are the tips for economizing it? Anyone would like to suggest? Because tips, I don't know. What are the tips? Yes. Anyone in the audience? So I think generally when you are supposed to provide this kind of a system, the SMRFs form your perimeter frame usually. So it is on the perimeter that you try and provide SMRFs, moment frames. And generally in taller structures, you see this kind of a system being followed more, where you have perimeter moment frames and shear walls in the inside periphery, lift cores or internal portions. When we do this, then there is an inherent problem of torsion. So that has to be taken care of when you go for shear walls that are placed uh, in the internal area. What I mean to say is, if this is your building plan, generally in these kinds of systems, SMRFs are on the perimeter because architecturally it is easier to integrate perimeter frames, and you will usually see core walls inside, whatever. Okay, and then you have perimeter frames. So this can be even your flat slab construction where you have a perimeter frame, and then you have slab with minimum or low amount of beams. So in this, the problem of plant torsion has to be sorted out. So that needs to be sorted by adjusting the stiffnesses of the frames, perimeter frames, so that plant torsion can be taken care of. So that is one issue that you will face if you give this kind of a system. Architecturally, it is easier to have this kind of a system with better space planning. Shear walls, although it is better to have shear walls on the periphery, but usually you may not be able to provide large shear walls on the periphery because of the parking issues and ingress outgress issues, because you want to enter the building. So if you have large shear walls in plan, it can be a problem. That is another point. uh, Seismic design, when it comes to seismic design, you need to follow the independent provisions of moment frames and shear walls. Plus, there are some additional requirements for dual systems that you have to follow as per IS 13920. Uh, what else? What else? So, Mr. Muhammad Rehan is saying better system with columns and beam spans can be economical. So, he's saying that instead of going for dual system like this, better you try and provide moment frames. Yeah, so moment frames have better ductility than a dual system, but in some cases you might have to integrate shear walls with SMRFs. So that is also there. So not many points are coming to my mind right now regarding this. Anyone from the audience wants to provide any more comments? Okay, so then we move on to the next question. Next query is next query is from let me see. Next query is from engineer Sumit Palde. He is from Nashik. He is a postgraduate student. If there is expansion joint in building, if there is an expansion joint in building and while doing foundation, how to transfer that load on footing? Because due to expansion joint, we have modeled separate building in ETABS, but while doing foundation, it has to be one. So how to transfer that load on another column? Yeah, good. So there can be multiple ways to do this. So suppose this is a building and then you are having to provide an expansion joint. Okay, so now how to do these kinds of thing in software? So there can be multiple ways to do this in software. One of the ways can be, oh wait a minute, Mr. Rehan is saying we can economize with performance based design. Okay, so I don't have much idea and working experience and knowledge about performance based design. So if you have more inputs about it, you may please share, because I don't have, as of now, I don't have much of working experience on performance based design. So you are welcome to share uh, any more inputs about it. Okay, so coming back to this query by engineer Sumit Palde about expansion joint. So suppose you have this two buildings, I mean one building which has been separated by expansion joint. Okay, assuming it also takes care of the seismic gap, etc. So now now you what you can do, because in footings, so what will happen that you will have double columns over here. Let's say double column system you have provided, but you are going for one footing. So footing is common, columns are two. So now how to transfer the load? That is the question. In some cases, we do another, I mean, in some cases where we plan expansion joint, we do this kind of a work also, that across the expansion joint, instead of providing double columns, because double columns don't look good architecturally. So what we do is that columns we take with a little setback, and this is your cantilever slab, and here we provide the expansion joint. Okay, so what happens then, the double column problem is solved and each column can have its own footing like this, and we are taking the slab cantilevering out and managing the expansion joint. So this can be another way, but let's just you are doing this way where you are providing double columns and you want to provide a common footing. How to do it? Because you have created separate models in ETABS. So now one of the ways is to create one model in ETABS, one model which will have which will have separations. So in a single model we are creating these two portions with an expansion joint, and then you take it to export it to safe, so automatically everything is taken care of. This is the easiest way to do it. uh, So what I'm saying, in ETABS, let's say you create one ETABS model which will have two portions, one and two. It will have a gap, and at this gap you have provided double columns, and then you bring it to save. In this, the problem will be of earthquake load application, so you need to be slightly careful about it. So maybe you can give some diaphragm assignment and apply the loads. Here you need to be slightly careful. This can be one of the ways to do it. The other way can be that you create one ETABS model. This is your one ETABS model. Okay, this is your second ETABS model. You analyze them separately, independently of each other, and then these two models you bring it to a common save file. These two models you bring it to a common save file. So this also you can do. This will require some jugaad on your part, but can be done. Okay, so this can be another way of doing it. So either of these two methods, whichever you feel more comfortable and convenient, you can adopt. Clear? Okay. So this was his question. Then what else he is saying? Okay. Then Mr. Sumit Palde has put more queries. So let's take up them. What are these? What stiffness modifiers are given for spandrels? So spandrels, as you know in elevation, if I show you, these are connecting link elements or link beams between two shear walls to get a coupling action for them. I am showing you the elevation. So if this is my shear wall in elevation, this is my shear wall, this is my coupling beam or spandrel. Okay, and in plan, how this will look like. So in plan, it will look something like this, where I have a shear wall in plan view, and then this is my spandrel element. So what he is asking, Mr. Sumit, what stiffness modifiers are given for spandrels? So it's not clearly mentioned in the IS 16700/2023. The modifiers for spandrels are not clearly mentioned. So what you can do is, depending on the L upon D ratio, suppose this is L, this is D. My suggestions would be, if your L by D is less than 2, then mostly you will get a shear controlled failure, or the design will be shear controlled. If your L by D is greater than 4, the design is usually flexural controlled. In between, it is intermediate behavior. It is intermediate behavior. So if your configuration is such that L by D is greater than 4, flexural control, maybe you can give the modifiers that are given for beams. Okay, so you give the same modifiers that are given for beams. This is one of the approach you can have. Then if your L upon D is less than 2, that means the behavior is shear controlled. Then you don't have much information. Even in ACI 318, I think they have not given specific information regarding shear control failures and what modifiers to take in such cases. So you do not know what to take. Okay. So as long as you have a L by D more than 4 flexural control, you may give the same modifiers as that for beams. Other than that, not much information is available. So I really don't know what are the appropriate stiffness modifiers to be given. Okay, maybe you can continue giving the same beam modifiers, but you don't have enough information about it. All right. Okay. Then he's saying, as in tall building course, so he is a participant in the tall building course. You have mentioned to place shear walls in such a way that it will not take axial tension. Yeah. So how to decide its position? No, so deciding its position means you provide it at locations where it will take substantial gravity loads also. Understood? So what happens, for example, if you place a shear wall near a large opening? So less amount of axial forces will flow to, or gravity forces will flow to shear walls. So when you do the dead load and EQ combinations with whatever appropriate factors, you may see that there is a net tension coming. Although the possibility is very low, especially in tall buildings, but then if your gravity load flow is less, maybe you are getting net axial tensions. Or suppose you are placing shear walls on the peripheries, it is subjected to large EQs and less gravity loads. Again, net tension possibility is there. So you have to be careful about its placement and try to place it in such a way that good amount of gravity load flows to your shear wall. This criteria is not very clearly explained in the code, because in the code it just says, I'll just open the code. The nominal design shear stress shall be limited to tau c max in structural walls that do not sustain tensile axial stress under any load combination, while the nominal design shear stress shall be limited to zero point 0.5 tau c max in structural walls under tension in any load combination. So, okay, so tension in any load combination, although is quite rare, but then these types of positions you should try and avoid. Okay, try to have shear walls at such locations where large amount of gravity loads can also flow in them, so that you can economize the design of shear walls. Okay, then his next question is, what modifiers to give for basement walls? Again, IS 16700 does not tell anything about it. Now, it does talk about walls, but those are mainly your RCC shear walls or structural walls, and those are mainly there to take the in plane moments. So, for in plane moments, if you see, the modifier given is zero point 0.7 and zero point 0.9 for strength and serviceability. But in basement walls, what may happen? They have to take the out of plane loads also, out of plane moments also. So modifiers for out of plane moments are not mentioned anywhere properly. So you really don't know what to do. Maybe you can give the same modifiers as that of columns, because columns are subjected to biaxial moments. So maybe for basement walls, you can give both the in plane and out of plane modifiers. So in plane modifiers, you can give them similar to shear walls. Out of plane modifiers, you can give them similar to columns. And what you will observe is that walls and columns both have the same modifiers as per IS 16700. So you will end up giving similar modifiers to basement wall uh, for in plane and out of plane action both. What I mean to say is that if this is my basement wall in plan view, let's say this is a basement wall in plan view. Now this wall can be subjected to, this is plan, so this wall can be subjected to both in plane and out of plane. So what you give for in plane moments, you give the modifier same as that of walls. For out of plane moments, you give the same modifiers as that of columns. Now if you notice the code, both the walls and columns have the same modifier of zero point 0.7 times IG for strength design and zero point 0.9 gross moment of inertia for service design. So basically you will end up giving zero point 0.7 modifier to both in plane and out of plane moment to basement walls if you are uh, using the strength design, and zero point 0.9 if you are using the service design. Okay, all right. So this was his query. Then what else do we have? So this was engineer Sumit Paldev with his queries. Now we move on to next question. Next question is from SV Muthesham Ahmed. He's from Hyderabad, and he is saying he's a working professional. And what is this question? Let us bring it over here. In case I am getting a circular column changing in a rectangular column as I move up above 17 floors, resting on that junction where depth of rectangular column is more than dia of circular column, beams are present attached to circular column. So I am assuming that extra portion of rectangular column offset load acting as point load, due to which I am getting more shear force at the beam ends for which beam is failing. It has to be designed as LLRS system. Client is not accepting gravity load resisting system. So what he is saying basically, if I am understanding correctly, let's say this is his beam cross section, and he had a circular column over here at lower floors, and as he is moving up, that circular column changes to a rectangular column where the depth of rectangular column is, so something like this is happening. Let's call this as D2, D1. So this is circular column, this is a rectangular column, and this is the beam, and you can see the D1 is the circular column dia, and this is the dimension of rectangular column. I'm not sure about the width right now because he has not mentioned anything about the width. Then his question is it required to design it as a strut and tie method, or else normally consider extra portion of column as point load and continue with the design? If I do so, how to solve more shear acting on beam which is due to point load because of overhang of rectangular column? Interesting. So I don't know what to do. Maybe maybe you can also use the shear enhancement approach. Let's say if this is your depth of the beam, effective depth of the beam D. This is a case where, let's say, load is acting from this column, okay, and then it will be transferred to this below column. Now because you have a larger dimension of this rectangular column, some of the portions are overhanging, so to say. So this is overhang portion, this is overhang portion, this magenta thing, this is overhang, and this is overhang. Okay, so basically what you want to see, what is the effect of this overhang and the load acting on this overhang on this depth of the beam, and how that gets transferred effectively to the column below. So he is asking, is it required to design it as a strut and tie method? See, strut and tie method approach can also be used. Strut and tie method approach can also be used. That can be one of the ways, or else you could just approximately calculate some sort of UDL acting. Yeah, how will you calculate the UDL? Because let's say you know the axial loads, you know the moments in this column, and using that you could come up with a equivalent UDL acting over here. Here, so it may be P by A, where P is the axial load, and if there is moment also, it can be M by Z. Using that you could find out the UDLs, and then what your approach is, that roughly this is the width of the support, so to say. So these are my additional overhangs, and then on these additional overhangs you could find out the, so basically your thing simplifies to, you have a span which is having D2 dimension, and then it is supported over a distance of D1, and then there are overhangs on which you apply this load that we have calculated, and then whatever are the moments and shears in these overhang, you ensure that this beam is sufficient to take that moment and shear. I think this can be one of the approaches. Okay, or you could use the strut and tie method also. So something like this you can do, instead of doing it as a UDL, I mean instead of using it as a point load, I think the UDL assumption would be better. Instead of doing it as a point load, UDL assumption is better, I think. Yes, so he is Mutesham. Can I design it as a corbel? Corbel. I don't think so. I mean, yeah, corbel is also you're doing the same thing. Corbel is also you're doing the same thing using the strut and tie approach. Maybe you could do it. Flare the circular column from 15th or below. Okay, so he is replying to the question, I think. Mr. Adil Khan is saying flare the column. Okay, so he's giving you a suggestion. That might not be, I think, architecturally possible. That's why he's not doing it. Yeah. So I would have used this kind of an approach instead of using it as a point load. I would do it like this, where uh, I would approximately calculate this kind of a UDL depending on the column loads, and then do this kind of a simplification calculation, and accordingly ensure that sufficient stirrups and reinforcement is provided in this portion of the beam for this load transfer. Yeah. Any other comments on this from live audience? As load is taken as UDL, is it at the face of columns or shear near the support is more? Yeah, it will be more, and then you will have to take care of it. Correct. You need to take care of that shear transfer. Correct. So if your concrete depth is sufficient, good. Otherwise, you provide stirrups. Uh, you provide stirrups. If your shear force leads to the tau v getting beyond tau c max, then you may have to increase the depth also of this beam, at least at these junctions. Yes. Okay. So these are my suggestions on this query. Very interesting. Uh, then let's see what else do we have. Mr. Rehan is providing one input. Beams can be designed as shell elements and load distribution can be easy and well distributed. So he's suggesting you that instead of going for a manual calculation with line elements like this, maybe for this portion you could develop a model with shell elements, and you will get better outputs from the software, and you would be able to accordingly design for it. But then in this case, when you will do it as shell elements, you won't get the forces properly. Then to get the forces integrated properly, maybe you will have to create strips if you are doing it as shell elements. So I think it will become more complicated if you use shell element modeling approach. So simplification would be, this is good simplification, I think. Simple, this simplification is good, I guess. Okay, interesting. Then we move on to next query. Next query is from engineer Akash Babar. He is from Mumbai, Maharashtra, and he is a working professional. Need guidance on design of RCC wall, approximately 3-meter height. Refer images on WhatsApp. Very good. So, just a minute. So this is engineer Akash Babar from Mumbai, Maharashtra, and okay. So he has shared some images. Let me just bring those images. He has shared it in document. Just hold on, I'm just bringing those images. So this is one of the images he has shared. Foundation plan. And then what else he has shared? Tank elevation. This is the elevation he has shared. And what else? Section also he has shared. Okay, good. So these are his inputs that he has given for the query. And now let's see what he wants to ask. Uh, Need guidance on design of RCC ring wall. Okay, he has shared one loading data also. Um, okay, so this is the loading data that has been shared. Then this is the tank elevation. I don't know if it's clear from here, from this image. So what you can see is this is the ground level, it seems. Somewhere over here is the ground level. And then you have got a tank. Is it correct? You have got a tank over here. And then it has a underbelly like this also. And these are the walls, RCC walls. On the RCC walls, you need to support this tank. Yeah. And in section, it is looking something like this. Oh, okay, sorry. This is the elevation mine. Acha, this is elevation. This is bottom of foundation. Yeah. So in sectional view, it is something like this. You have the tank wall. This is the RCC wall, ring wall. That means in plan view, it will be like this. And then you will have a circular raft or rectangular square raft at the bottom over here, and you are filling it up with sand, whatever. Generally, why these sand fills are done to increase the weight. If toppling or overturning is a problem, you just fill it up with sand to increase the weight of the system. So yeah, and this is the plan view. I think in this plan view now it's clear. This is your ring wall. This is your ring wall. Below it is your raft, and you are filling this cavity by sand. So what is this question? How to do this? So what are the tips to do this? What are the inputs given? So they have given you the wind forces and moments. So this is the base shear, so to say, and this is the overturning moment. It's not much. Then you have got seismic shear and overturning moment for seismic loads. Now magnitude wise, I think which is the higher? Just compare the magnitude. Okay, so seismic is higher. Seismic looks like higher. So 32,994 kg force. So in kilonewtons, how much will it be? Divided by 100. Am I correct? 32 kg in kilonewtons divided by 100. So it will be 329 kilonewtons. And kg force meter in kilonewton meter. How much will it be? So this is already meter. So again dividing it by 100. So it will be 2775. So this is your P. Okay, sorry. This is your actual lateral force, and this is your overturning moment. In addition to it, you have your axial loads also. So you can figure out the axial loads. Fabricated weight is this, empty weight including internal and external, whatever this is, insulation, whatever. So you can add up the axial forces also to get the P. This is your M. So when you want to design this kind of a ring wall, what you can do, number one, approximately manually you can do it. How you can do P by A plus M by Z. Okay, where what is your P? So your P is going to be the axial force, and what is going to be A? A will be the plan area of this ring wall. So A will be this plan area, this, correct? So on this your P is acting, and about one of the axis your M is acting. So A will be the cross plan area of the ring section. Z will be the section modulus of this ring raft about the axis. So about this axis, you calculate the Z of this ring raft, ring so to say, this hollow ring. You can calculate the Z. You do P by A plus M by Z. You will get the stresses. Let's say Newton per mm square you get. Now you will see that the axial stresses will be so low that it will be less than the compression capacity of pure concrete, which we take around 0.446, or in bearing how much we take? 0.25 fck in bearing. Or even if you were to compare it with 0.446 fck, which is the ultimate strength of concrete in compression, you will see that what I can looking at the values, what I can judge, that your P by A plus M by Z will come to be less than 0.446 fck. If it is so, that means you do not really need reinforcement to take the axial loads. Okay, the concrete cross section is enough. So if that is the scenario, then you provide minimum vertical reinforcement. Okay, you can provide minimum vertical reinforcement. Additionally, you find out P by A minus M by Z also. You check what is the tensile stresses. See if that is less than the rupture strength. What is it? Point under zero point 0.7 under root FCK. So you calculate what is the rupture strength of concrete, whether it is less than that or more than that. If that is the scenario, then I mean, if your P by A minus M by Z is less than 0.7 under root FCK or tensile rupture strength, whatever, then ideally you do not need any tensile reinforcement also. If not, you can provide tensile reinforcement accordingly. Okay, so this can be another way you could do it. Then the next thing you need to do is, in this case the axial loads are not much, but sometimes what happens is that if your wall aspect ratio, for example this is my cross section, okay, and your wall height and this depth dimension, diameter, what thickness t, depending on this height to thickness ratio and the load that is acting, you may get vertical bendings also. So you need to take care of that vertical bending also. Now I think there are some manual calculations to do this vertical bending calculation. If not, you could just create a simple shell wall model, create a shell wall model in ETABS or STAD, whatever, and you could even apply the loads. The P load you could uniformly distribute, and to distribute the M load, maybe you could create some sort of a diaphragm assignment, apply a M moment so that the forces get transferred to all these shell points. That is one of the ways you could do it. What I'm, I mean, what I can think of can be a way that you create a shell model and you apply a moment, apply some constraint assignment, diaphragm assignment, okay, so that the forces are transferred to each of the peripheral points, overturning moment, and then see what is the vertical moment in ETAB. Let's say if you are doing, what is the M22 moment you are getting because of it, and then ensure that your vertical reinforcement that you have provided is sufficient to take care of that M22 also. Usually this calculation that you will do from here and the reinforcement that you will give, usually it will be sufficient to take that M22 moment, but you may see that at the base you require some additional extra reinforcement, vertical I am talking about. So this can be the second thing you need to do. If you're not able to understand this properly, maybe Another approach could be that instead of creating a complete ring model, you create a smaller model, just 1 meter maybe. Okay, or you create a single line element, and on that line element you apply this kind of a, no, but this will not help you. You need to create a 3D shell and try to apply a moment, and ensure that the moment gets transferred to this ring wall. Okay. Yeah, in fact, if you create a shell element properly, if you create this kind of a shell model properly, and even if you apply just vertical loads which are coming from P by A plus M by Z, then also you will see M22 or vertical moments getting generated. So try this out once. Okay. The second thing is whether there is any load due to this surcharge. So how will the surcharge come? Because your grade slab over here is loaded, and from there the surcharge loads are transferred to this wall. So you need to check that also. Okay. But I think as per your cross section there was no load on the slab, what I could see. Grade slab not carrying any load. Okay, so grade slab is not carrying load, so there is no surcharge, there is no lateral pressure. But then below NGL there will be some amount of lateral pressure from soil. So for that you may have to calculate these hoop tension uh, reinforcements. But then again, because wait a minute, but because the soil pressure is from outside. Okay. Even if there is no surcharge, there is sand fill from the inside that will also have some pressures. So you can calculate triangular pressure due to sand from outside, subtract the soil pressure acting. Sorry, I'll repeat. You calculate the soil pressure acting from inside, sand pressure acting from inside, subtract the soil pressure acting from outside, and for the net effects you will have to calculate the hook tension reinforcement. Accordingly you can provide the hook tension reinforcement also. What else do we have? And then for the footing overall stability for this raft sizing, you could do same P by A plus M by Z once again. This time when you are taking the P, you take the axial forces from the silo, your steel silo, whatever, plus the self weight of the sand, and the area will be the plan area of the raft that you're providing. Overturning moment you already know. Z will be the Z of this complete raft. So using that you could do the foundation sizing also. And then once you know the pressures, you can do the thickness calculation for the raft also. So I think these things you could adopt. This step by step approach you could adopt for this kind of a design. Okay. All right. Then we have next question from engineer Swapnil Mure. He is from Mumbai. No, he is from Pune. He is a working professional. He is asking, what he is asking. Please explain backstay analysis. So backstay analysis means that when we have a structure and there are some, so this is my building. It has multiple floors, and then I'm drawing a cross section right now, and then let's say there is a podium slab over here. These days you have got podium slabs which has a larger footprint, and maybe it is connected to basement walls. So what happens is that when your lateral loads are acting due to wind or seismic, you will see that you get a restoring action from the this level, the ground level, podium level, and the below levels. Okay. So if you had a standalone building like this, it would have got no restoring effect against the lateral load. But in this case, what is happening? You are getting a restoring effect against the lateral load because of the presence of a larger slab area over here, and because of this, it basically reduces the lateral displacement of your structure, lateral displacement of your building. It also leads to reduction in base shears, overturning moments, etc. So this is called as the backstay effect of, or the backstay provided by the podium slabs and levels below. So you need to do certain analysis for this, and that is called as the backstay analysis. It is given in IS 16700. You could read through them. Also, in our course on tall buildings, we have discussed this in a lot of detail. So you could uh, look at our course as well. Okay, but the basics you will understand once you go through the uh, text of 16700. Okay, so these were the queries on the Google form. Now let us see. There are no queries on the mail. So now let us take up the queries from the live comments. So first query is from Structure Architecture 2779. I want to connect 200 cross 300 cross 10 thick RHS tube section to face of 300 RCC column. How can I connect it? I want to connect 200 by 300 by 10 thick RHS tube to RCC column having 300 face. How can I connect it? There will be only 50 offset left on either side of the beam. So there can be multiple ways. One of the way that comes to my mind, what he is saying is he has a column RCC. I am not sure about the size, but one of the face is 300 Let me just draw a plan view. So he's saying this dimension is 300. I'm drawing a plan view right now. And then this is the RHS rectangular hollow section tube. He wants to connect. In plan view, it is 200 width. So the offset left is 50-50. Okay. So he wants to connect this in section view or in in elevation view. This is his column and this is his RHS. And the depth of RHS is 300, I think he's saying. What is he saying? Yeah, 300. So how to connect it? So one of the options could be, I'm just giving one of the options. There can be several different approaches. So right now we are only assuming a shear connection, not a moment connection, because a rigid connection may be difficult to manage. So one of the options can be you provide a top bottom cleat. So there will be a cleat at the top, cleat at the bottom, and you provide bolting in this. So there will be bolting. You may go for through bolting also. Okay. So in top view, let's say you provide bolts like this, maybe. And these are through bolts. This can be one of the ways to do it. So I have provided top and bottom cleats, and then I have provided through bolts. So there will be hole in the cleat over here. One face of the cleat is connected to concrete. Other face of cleat has holes, and then there are matching holes in this RHS. If I draw the cross-sectional view of this RHS, it is looking like this. This is 200. This is depth is 300. Thickness is 10 So you can provide through holes in the RHS, rectangular hollow section, have these cleats, and using this approach you could connect. This is one of the possible ways. The other possible way could be that I have a plate. Other possible way is that I connect a plate first to this RCC column. So there is this plate that I have connected. Okay. And then on this plate, I connect a stub. That stub is of the same RHS member. Okay. And then I can create a connection over here. Is this clear what I'm saying? So what did we do in this? We had a plate first connected to my RCC using lugs or whatever. So there is this plate, then you have this stub, sorry, you have this stub, and then you make the connection over here. Now that connection can be using flange type of connection, or you could come up with splice connection, whatever. There can be different options to it. uh, in depth 5677 is saying plate attached to columns with j-angle. Yeah, so you could have this plate attached to the RCC column through lugs. uh, Before, I mean, during the casting itself, you could do it and then make this kind of a connection. So this can be the other way to do it. Third way to do it could be that if this face of the column is available, it depends. If this face of the side face of the column is available, you could think of connecting some side plates like this, okay, and side plates like this. Now there is a gap of 50 mm, so maybe you need to have some sort of element welded to the sides and then do some sort of a through bolting. So this can be another way to do it. So there can be multiple options. In fact, even if you don't have any packing provided, still I think it can work, because it will be a shear connection, so it is resting on the bolts itself, shearing on the bolts itself. So this can be another approach. This side plate is connected to the RCC, so this will look something like this, where you have a side plate connected, and on that side plate, of course, that face of the column should be available to you for that side face thing. But if it is available, so this is my side face, and I manage my connection on that side face like this by providing maybe bolts on this face of the RHS. So there can be multiple ways. I just uh, tried to present three ways that come to my mind. Okay, what has happened? Arre. Ah. So I just tried to present three ways that have come to my mind. Of course, there can be other options also. Good. So this was structure architecture 2779 with this question. Then we have Engineer Adil Khan. Can you please explain when to take only one CPI and when to take both plus CPI and minus CPI, and which is good for economical perspective? So what his question is, let me just try to explain. See, generally when we are doing shed-like structures or any enclosed structure for wind, what happens is that there is a CPI also and there is a external pressure also coefficient. Now the internal pressure has, our code says that you have to take two possible directions. Okay, so your internal pressure could be like this also, it could be like this also. So on each wall you are supposed to take both suction and pressure of the CPI. What that means is that you have to consider both possibilities. Once your CPI is acting towards the wall, and secondly, it is acting away from the wall. On roofs also acting towards the roof, acting away from the roof. So CPI has two possible directions. CPE has, the direction of CPE depends on the configuration. So generally, let's say your CPE will be like this. For a slant roof, usually your CPE direct values will be like this. So now Mr. Adil's question is, there can be two approaches. I'll just take some values. Okay, so let's say this is 0.7, this is 0.5, this is 1.1, this is 0.9, and CP, these are external coefficients. Internal coefficients to be taken is plus minus 0.2. So one of the approaches to numerically take the highest values, and for that you adjust the CPI direction accordingly, so that numerically you get the highest values of CPE minus CPI, because code wants you to do this. So I have taken the arrows of CPI in such a way that I will get the numerically highest values when I combine the CPE and CPI. Is this clear? This can be first approach. So finally, effective values, what am I getting? So effective values I am getting are, on this phase I get zero point 0.9, on this phase I get 1.3, on this phase I get 1.1, on this phase I get 0.7, and I design my shed for it. So this is a simplistic way of doing it. This is a simplistic way of doing it. In this case, we are ignoring some of the possible combinations, and this is slightly less economic, I would say. Okay, but because this is not a realistic case, this is slightly uneconomic, and we are ignoring a few possibilities in this, but this is easier to do. And let's say if you are doing such things for the first time, in my opinion this is a good way of doing it. Okay, so therefore in one of our courses we did it like this, because uh, it was a course where we just wanted to explain what needs to be done in a easy way. So this is a good way. We do miss out on a few possibilities, but then that's okay, we can live with it. The second way to do it is, which is the more appropriate way, would be that you take two possibilities. Okay, in this, once you consider CPI acting, let's say all the coefficients are acting towards the wall. So now just help me out with this. These are my external pressures, and CPI was 0.2. So what is the effective value I am getting now? Just tell me. So this will be one of the way. This will be one, and then when I am getting CPI, all CPIs I will take away. Is this clear what I'm trying to explain? CP, of course, remains the same. So now just give me the values that we are getting. So now the values that you will get will be, in this case, this is 0.9. What is this? 0.7. Sorry, this is 0.5. And in this, you will get, what is this? 0.9. This is 0.9. This is 0.5. This is 0.3. So now you analyze your shed for these two separate cases. Okay, this is more correct way of doing it. This leads to some unbalanced movements that you are missing out over here, but because it is slightly more complicated to do it in software, the easier approach could be something like this, that I discussed earlier. So is it clear? So this is case A of doing it, where you just make one possible combination like this and analyze your frame. And this is case 2 of doing things. This is more appropriate, where you make these two types of different load combinations, and you are considering two possibilities like this. Is it clear now? Okay, good. So this was his question. Then Mr. Akash Babar is asking, in my question, can we use section 32 of IS 456? What is section 32? I don't know. I need to see. Section 32. What What is section 32? Let me just check what is section 32. Section 32. 32. Wall subjected to combined horizontal and vertical forces. Yeah, you could use this. Appropriate requirements, you could use this. Yeah. Section 32 is for walls. You could use this. Any appropriate provision, if you feel, yes, I think you can use. Okay. So I think that's all for this session then. That's all. We have taken up the questions from the Google form and from the live comments. So this is all for this week. And you could continue to paste your questions in the same form once every week. As you all know, we conduct this live session, but throughout the week, you can use the same Google form for putting in your queries or doubts or difficulties. So I'm just putting the link for that Google form over here. So this is the link for Google form. You can use it. And if you want to connect with us on WhatsApp, you can click on this link. I'm just putting it over here. Just a minute. Where is it? Yeah. So if you want to connect with us on WhatsApp, this is the link to do it. I've just put it in live comments. So this is it then for this week. Thank you. And now we will see you on next weekend. Till then, bye bye and have a good time. Bye bye.